The parameter size of the model refers to how many numbers we used in a model to predict the next word. So say we had the word hello over here, and we wanted to predict the next word that comes after that, the next most likely word, which in our case would be something like world. What we need to use some amount of numbers, which we learned through the process of training. So this is our large language model over here, which has a bunch of numbers in it. And using these numbers, we learned what words come after hello. And we didn't just learn this for one word, we learned it for all the words in the English language and most possible sequences of words as well. So the parameter size means how many numbers we use to predict the next word. And this has implications like the bigger your parameter size, the more accurately you can represent the meaning of a word because you have more numbers to represent it. Like I used the example of cat for embedding, where to represent the meaning of a cat, which was a furry, four-legged creature, we used two numbers. One for the amount of fur and another for the amount of numbers. But if you have more than two numbers available, you can represent a cat more accurately. Like the fact that it has a head might be another number. The fact that it has a tail might be another number. And thus, the more numbers you have, the more accurately you can represent the meaning of words. And due to this, it's more likely that you'll get a better, more accurate word out at the end. So that is why when you're choosing a large language model, it's not good to go for something like 1 billion parameters, because that might not have enough numbers in it to represent everything accurately. Whereas something like 400 billion parameters will probably be able to represent all of the internet's worth of text complexity. So that is parameter size, and that is why it's important to be able to have a large number of parameters to be able to represent all the meanings of the words correctly.